All right. Share here. All right, any questions that we did last time? We're going to finish up chapter 15 today. We did divisions by monomials and also divisions by binomials. So today we're going to do chapter 15, section 8, scientific notations. It's called scientific notation is because in science, we use numbers that are very, very, very large and also very, very, very small. For example, the distance between the Earth and the sun. Oh, so it's Earth, moon. 93 million miles. 186,282 speed of light. So imagine multiplying these two together. I'll be a very, very big number with a whole bunch of zeros everywhere. Those are like astrophysics. In biology, you can have things that are very, very small. It's the weight of an atom. Very small. So how do we go out and manipulate? How do we move these numbers around? How can we multiply these things? That's what scientific notation is all about. Scientific notation creates another representation of a large or small number into two parts. The decimal part times an exponential part. Scientific notation creates another representation for a number that's very large or small by taking the number and making a decimal part and an exponential part. So before we get going with this, let's look at the exponential part. 10 to the first is what? 10. 10 to the second is what? Yeah, it's 10 times 10, which is 100. What is 10 to the third? That's 10 times 10 times 10, or 1,000. We'll do a couple more. What is 10 to the fourth? 10 times 10 times 10 times 10, or 10,000. And one more. Good morning. 10 to the fifth. 10 times 10 times 10 times 10 times 10, That's 100,000. What I want you to notice is first, the exponent on the 10 also relates to the number of zeros after the numbers. 10 to the fourth. That means I'm going to have 4 zeros after the number, after the 1. That's the first thing. Because it's positive, the zeros go that way. It's positive. One over 10. In exponentials, how would we write that? Remember, a negative exponent tells you that all you do is change the location of it. But what is 1 over 10? That's 0.1. What is 1 over 100? Since there's 2 zeros, -2. The answer is 0.01. 1 over 1,000, 10 to the -3. Actually, what I should have done is this. I should have done this, okay? This is 1 over 10 to the first. Because it's on the bottom, we can bring it up, change the sign. This is 1 over 10 to the second, because there's 2 zeros. We can bring it up to make it negative. This one is 1 over 10 to the third. Since it's on the bottom, we can bring it up top, make it sign negative. 1 over 10 to the fourth is 1 over 10,000, which is 10 to the -4. So what do you notice about the negative exponents? This one is 0.001, 0.0001. So what do you notice about the negative exponents? What happens to the numbers there, the decimals? If you have a negative exponent, that means the number is very small. The bigger the negative exponent, the smaller the number is. But more so, what direction is the decimal moving? We start off with 1, right? So now it's 0.1, 0.01, 0.001. The decimal with negative exponents, the decimal goes to the left. All right, so positive exponents move the decimal to the right. Negative exponents move the decimal to the left. How many spaces do we move it? Well, whenever we have 10 to the n. N can be positive or negative. Move it n spaces. So if I had 10 to the negative 5, I start with the number 1.0. Which direction do I move the decimal? Move it to the left 5 spaces. So that's 1 space, 2 space, 3, 4, 5. So that's 0, 0, 0, 0. So the number is actually 1, 2, 3, 4, 1. There's my number. Because you have to have a number to begin with. And why do we start off at 1? It goes back to this. We know 10 to the first is 10, right? What is 10 to the 0? 1. So you begin at 1. And from there, the numbers increase. So if I move it, right now it's the decimal is right there. 10 to the first, I move it 1 space to the left. I have 10 now. I move it another space. I have 100. So every time you move the decimal, that's a factor of 10. How would you write that number? Without exponents. Okay, there's your number. This thing tells us what to do with the decimal. Which direction do we move it? Left or right? Why left? Because it's negative, the decimal has to go to the left. How many spaces? 3. This tells you the direction. This tells you the number of spaces. So from here, I move it 3 to the left. 1, 2, 3. So my final answer is 0.42375. There's my final answer. Let's look at another one. Rewrite that answer. What direction do we move it? To the right, because it's positive. How many spaces? 6. So we move it 1, 2, 3, 4, 5, 6. So how many zeros do I need? I need 1, 2, 3 zeros. Because I already have the decimals here. It has to move 6 spaces. There's 1 space, 2 space, 3 space. Since there's no more numbers, each space is a 0. Since I have 3 more spaces, let's put 3 more zeros. How about that one? Good, because so it's 0.614. Is that what you're saying? Let's see. So we have to move it to the left. 4 spaces. Where's the decimal right now? It's after the 4. If there's no decimal in the number, it's always after the last digit. If we move it 4 spaces to the left. 1, 2, 3, 4. So we have to have a 0 there. So the answer is 0.0614. Write that as a scientific notation. I'll tell you what scientific notation looks like. So we'll do this in a second. So scientific notation has this format. Scientific notation has that format. Okay, now what does it mean to you? What it means is this. No matter what you have, in the final form of scientific notation, you'll only have one non-zero number in front of the decimal. Then you have the decimal, then you have all the other numbers. So in other words, you only have one digit in front of the decimal. That's the scientific notation. One non-zero digit. So let's look at these. So if I give you 63,000, how would you write that as a scientific notation? What's the number part going to look like? What's the first non-zero digit? 6. So we have 6.3 times 10. How many decimal places do we have to move it? Where's the decimal now? The decimal's at the end. If there's no decimal, it's always after the last digit. So to go from here to here, how many spaces do I have to move it? 1, 2, 3, 4. And there's your answer. With the exponent, the n, or 10 to the n, if n is positive, the number is large. If n is positive, the number is large. If n is negative, the number is small. What do I mean by large and small? Is 63,000 large or small compared to this number? Yeah, this one's large. This one is small. Look at it this way also. If you had a paycheck and it had, or which paycheck's bigger? Exactly, yeah. So the more numbers you have in front of the decimal, the larger it is. If you have zeros in front of it, that's pretty small. So Let's look at another one. Put that in scientific notation. So what's the number part going to look like? Very good. Oh, is this a large number or a small number? It's a large, so it can't be negative. So move it 1, 2, 3, 4, 5, 6. So it's 10 to the 6. Yeah, and that's why I just put that up there. If you're going from a large number, even though you're moving it these directions, this will tell us if the number we just changed is large or small. Since it's a positive 6, we know it's a large number. If it was a negative 6, it'd be a very small number. How about this one? Convert that into scientific notation. No, this is a trick question. Okay, the answer is remember, scientific notation, what's the format? You have to have only one digit in front of the decimal. It's there, so you can't go any further. You can't change it. Okay, convert this one. What's the number going to be? 5.71. Because we have to move the decimal right behind the first non-zero digit. It's a small number, so the exponent is going to be negative. How many spaces do we move it? 2. One more. Convert that one into scientific notation. What's the number gonna look like? Negative what? Very good. 1, 2, 3, 4. Make sense? A lot easier now? Yeah, the negative in front doesn't change anything. It's still a negative number. Okay, let's go the other way. I give you 4.2 times 10 to the 3. Convert that from scientific notation to a regular number. Is it going to move to the right or to the left? Yeah, since it's positive, the decimals are going to move to the right. We have 4.2, so let's move 3 spaces to the right. 1, 2, 3. So the answer is 4,200. You could put 4,200.0 if you want to, or just 4,200. They both mean the same thing. Does it move right or left? Very good. Right, 5 spaces. 1, 2, 3, 4, 5. And all these are zeros. $870,000.0. Do a couple more, then we'll combine these operations now. Right or left? Yes, since it's negative, we're going to the left. 3 spaces. So from there, 1, 2, 3. So we have 2 zeros in front of it. So we have 0.00642. It's a good convention to get into. Whenever you have a decimal and a bunch of numbers behind it, if there's nothing in front of it, put a 0. It just makes it look nicer. Is number positive or negative? Stays negative. Decimal moves which direction? Left 1 space. So one space, so it's 0.527 negative. So all it does is move one space to the left. Well, the whole, it's not the zero, this is one number. It's 0.527. It's one number, so yes. How about this one? That is a good question, though. Okay, zero, no, it's the zero is the coefficient, is the first of the numbers. So yes, that's the whole number's negative. Since it's negative, we move which direction? To the left, 3 spaces. So from here, so 1, 2, 3. So we have to add 2 more zeros there. So it's 0.1, 2, 3, 4, 5 zeros. Make sense? Is it okay? Now, I want you to convert these numbers, even though they are, it looks like scientific notation. Put that into scientific notation. $35.0. Okay, 35.0. Yeah, if there's no decimal, it's always after the last digit. So we know it's going to be 3.5 times 10 to the what? So what does this number here look like? Right now, this number looks like 35,000. That's this number. It has, after a decimal, I got 3 spaces. So what I'm really doing is I'm moving it 1 more. So this is to the 4th. So 35 times 10 to the 3rd is the same thing as 3.5 times 10 to the 4th. Because I'm giving it 1 more step to travel. No, 216.48 times 10 to the 5th. So what's the number part going to be like? What's the number part going to look like? Remember, it has to be only 1 digit in front of the decimal. So that's what new ones look like. When I moved 2 decimal places, I added 2 to there. In other words, the decimal has to now travel 2 more spaces to make that number. Let's look at a small number. So the number part's going to be 2.35. Very good. Very good. Because we have to add 3 more spaces, it has to travel. How about if we had this number, 242.3 times 10 to the negative 6. .423. What's this one going to be now? Whenever we move the decimals, like this one up here, we moved it 2 to the left, we added 2 more decimals. We move this one 2 to the left, we're adding 2. When you move to the left, you add. When you move to the right, you subtract. No, I'm talking backwards. When you move left, you add. Move right, subtract. Because here I'd move it 2 to the left, so I added 2. If I have to move it to the right, I subtract. But here's the case points. So here's decimal place. I'd move it 2 spaces to the left. Since I move it to the left, I add those 2 spaces to that. This one, I have to move it to the right 3 spaces. If I move to the right, I subtract. So -6 minus 3 is -9. This one here, I had to move it 2 to the left. So I add 2 spaces. -6 plus 2 is -4. So this is the in scientific notations. If you move it to the left, you have to add how many spaces you move it to the exponent. If you move it to the right, you have to subtract from the exponent. All right, let's see why we're doing this. Let's multiply some numbers together and divide some numbers. So what if we had 2 numbers, 2.6 times 10 to the 4th times 2 times 10 to the -6. Okay, so first thing we do here, we multiply the separate parts. So we have 2.6 times 2, and then the scientific notation part, 10 to the 4th times 10 to the negative 6. We're grouping them. 2.6 times 2. 6 times 2 is 12. 2, 4. This is 5.2. What's the exponent going to be? You have the same bases, you're multiplying them. What do you do with the exponents? You add them. So 4 minus 6 is, since they're opposite signs, you subtract them. Yes, you add them, but in this case, it's subtracting. It's 4 plus negative 6 is negative 2. So there's your new answer. 5.2 times 10 to the negative 2. Let's look at another one. 3 times 10 to the 5th times 10 to the negative 7th. I group the numbers accordingly. 3 times 5 is 10 to the 5th times 10 to the negative 7 is 10 to the negative 2 plus, yeah, we add them. So negative 7 plus 5, 7 is bigger, so the answer is negative. 7 minus 5 is 2. Are we done? No. Is this scientific notation? Where's the decimal here in this question, in this number? It's after the 5. Where should it be? Scientific notation, only one number is in front of the decimal. So since we moved it one to the left, what do? Do we add or subtract that one space? So what's the answer going to be? So negative 2 plus 1 is negative 1. Let me get another one here. 23 times 10 to the 5th times 3 times 10 to the 12th. So 23 times 3 is 10 to the 5th times 10 to the 12th is 10 to the, yeah, we add the exponents. But the decimals over here, it's got to be moved over 1. So we add 1 space. We move 1 decimal. Very good. So far, so good. Again, you'll need to refer to your notes when you do these for the homework, because what you do with the exponents when you move back and forth, it can get confusing. (4.8) times 10 to the second divided by 2.4 times 10 to the negative 3. That's like division problems. Again, we do these in two parts. 4.8 divided by 2.4. 10 squared divided by 10 to the negative 3. The easiest way to divide decimals is to get rid of the decimals. Since they both have to move one space to get rid of the decimal, it makes it much easier. How many times is 24 going to 48? 2 times. Now, what do you do when you divide exponential numbers? Remember what we talked about a week ago. When you're dividing them, you subtract the exponents. So we have 2 minus a negative 3. Minus and minus becomes a positive. So we have 2 times 10 to the 5th. There's your answer. See, everything we do in class builds on the stuff we talked about recently. All I'm doing is throwing in one more twist each time. Two times 10 to the 8th divided by 4 times 10 to the 15th. What is 2 over 4? It's 1/2. How about this? What do you do with the exponents here? Subtract them. So whatever's on top minus whatever's on the bottom. But what is 1/2? We have to have decimals. What is 1/2 in decimals? 0.5. 8 minus 15 is negative 7. Okay, it's not in standard notation. Decimal's in the wrong place. We have to move it 1 to the right. If we move it 1 to the right, what do we do here? We subtract 1. So the answer is 5.0 times 10 to the negative 8. Mhm. Let's do 3, 9. Multiply these two numbers together. So there are 5 zeros in the first one. There's 1, 2, 3, 4, 5, 6, 7, 8 after the decimal on the next one. So what's the first thing you have to do? Convert to scientific notation. What is this one going to be in scientific notation? The first non-zero digit is 7. How many spaces? 1, 2, 3, 4, 5 spaces. So the first number is 7.0 times 10 to the 5th. The second number is what? 3.9 times 10 to the 1, 2, 3, 5, 6, 7, 8, 9. Since I move it to the right, I subtract 9. Then we group them. 7 times 3.9, 10 to the 5th times 10 to the negative 9. .9 times 9 times 7 is 63. 7 times 3 is 21, plus 6 is 27 with 1 decimal space. And 10 to the what power? All right, plus 5. We have 5 plus negative 9 is 10 to the negative 4. But we're not done. We have to move it 1 space to the left. If we move it to the left, what do we do with the exponent? We add 1 space to the exponent. So it's 2.73 times 10 to the negative 3. Which would look like 0.00273. Because you could be asked to put it in both ways. Since the original question was given to you in those long and small numbers, it may want you to put in the same format. So far, so good. Here's an application. In physics, motion problems, distance equals the rate you travel times how long you travel. Distance equals rate times time. Rate is like miles per hour, feet per second. So a rate is a distance over time. Time could be anything like seconds, hours, days. Distance is in miles, feet, kilometers. So my rate of travel is 35 miles per hour. And I travel for 3 hours. How far have I traveled? I want to know distance. I want to know how far I traveled. So distance equals rate, which is miles per hour, times 3 hours. When we deal with application problems, notice here, the hours cancel. So we have 35 times 3, which is 105 miles. MI. So that's if I gave you rate and time, because that's on this side. What if I gave you the distance? The distance I traveled was 100 miles. And I did it in 5 hours. How fast was I traveling? What is my rate of speed? Let's see here. We have distance equals rate times time. Distance equals, we don't know rate, times time. Since we're looking for rate, we have to divide both sides by the 5. 100 divided by 5 is 20. So my rate is 20 miles per hour is my rate. So far, so good. Let's look at these. Speed of light is approximately 3.0 times 10 to the 5th kilometers per second. How far does light travel in 6.0 times 10 to the 1st second? In other words, how far does it travel in 1 minute? In 60 seconds. It's a motion problem. How do we know it's a motion problem? Because we're dealing with distance and time. What do we know out of these 3? Do we know the distance? No, that's what it's asking for. It's asking you how far. That's the distance. We don't know that yet. What's the rate? What's the speed that we're talking about here? No, rate is always a distance over time. Remember, speed is miles per hour, feet per second. So rate is always a distance over time. So this one is 3.0 times 10 to the 5th. What's the time? Which one of these deal with only time? 6.0 times 10 to the first seconds. You have this part with the application part, you have to play two games. The mathematical part, that's the easy part. But what you're reading here, when I say distance, what unit are we talking about when we talk about distance? What is distance referred to as in what units? Miles, feet, inches. Time is always in seconds, minutes, hours. So rate is miles per hour, feet per second, inches per year. So we put what we have. We're looking for D. So we have the rate, which is 3.0 times 10 to the fifth. Oh, this is also kilometers per second. Times the time, which is 6.0 times 10 to the first seconds. Because in application problems, we notice the seconds cancel out. So all we're left with is kilometers, which is what our units will be, kilometers. Multiply the numbers. 3.0 times 6.0. 10 to the fifth times 10 to the first. So 3 times 6 is 18. Same basis, so we add the exponents. 5 plus 1 is 6. Since we move the decimal 1 to the left, to get scientific notation, we have to add 1 to the exponent. So the answer is light will travel 1.8 times 10 to the 7 kilometers in 60 seconds. That's 1, 8, 1, 2, 3, 4, 5, 6. That's how many kilometers it's going to travel in 1 minute. That's far. All right, so when you do these word problems and these application problems, make sure that you label them appropriately and you have the numbers and the units that they're dealing with. Like I said here, kilometers per second. That's kilometers per second. Time is in seconds. Because when you finish the units, since we're looking at how far, that's a distance. Distance has to be in kilometers. It can't be in seconds. It can't be in kilometers or seconds. It has to be in units. All right, so that does it. End of 15.8. End of chapter 15. Now we're rounding into the last chapter of our course. Chapter 16. We're going to go backwards now. Chapter 16 deals with factoring. You remember what is factoring? From the distributive property, the first week of class. We just finished doing this. We just finished distributing. Now we're going to go backwards. We're going to factor. Remember these words? Greatest common factor or greatest common divisor. They mean the same thing. What we have to do here is we did this prime factorization. We take a number, break it down to its smallest pieces to see what it's made up of. That's the greatest common factor. And then we look at what they have in common. That's the greatest common factor. Let's look at the divisor rules. Here's some really quick. It'll help us doing this stuff. So a number is divisible by if. Okay. A number is divisible by 2 if it ends in 0, 2, 4, 6, or 8. So if the last digit of a number is 0, 2, 4, 6, or 8, then we know the whole number is divisible by 2. For example, 3, 5, 6. Is that number divisible by 2? Yes, because it ends in a 6. We know it's divisible by 2 now. 2 goes into 3 once, with 1 left over. 2 goes into 15 7 times with 1 left over. 2 goes into 16 is 8. No matter what you give me, I can, if it ends in an even digit or 0, it's divisible by 2. A number is divisible by 3 if the sum of the digits is divisible by 3. What does that mean? If the sum of the digits is divisible by 3, is 18 divisible by 3? Well, let's see. If we take the digits, 1 plus 8, that equals 9. Is 9 divisible by 3? Yeah, that means 18 is divisible by 3. Is 3, 5, 4, 3? Is that divisible by 3? Well, let's find out. 3 plus 5 plus 4 plus 3. 3 plus 5 is 8. 8 plus 4 is 12. 12, yeah. The number is 15 is divisible by 3. So that means this number is divisible by 3. Three goes into 3 once. 3 goes into 5 once with 2 left over. 3 goes into 24 8 times. And 3, so it's divisible. So that's how we test if a number is divisible by 3. It's divisible by 4 if the last 2 digits are divisible by 4. Is 5717, is that divisible by 4? The last two digits, 17. Is 17 divisible by 4? No. How about if it was 16? Let's see this, yeah. So this one says because the last two digit is divisible by 4, the whole thing should be. 4 goes into 5 once with 1 left over. 4 goes into 17 4 times with 1 left over. 4 goes into 11 twice with 3 left over. 4 goes into 36 9 times. Yes. So it is possible. A number is divisible by 5 if it ends in 0 or 5. Number is divisible by 6 if it is divisible by 2 and 3. So what does that mean? Number is divisible by 6 if it's divisible by 2 and 3, which means 1, it has to end in an even integer. And the sum of the digits have to be divisible by 3. So if both of those conditions work, it's divisible by 6 as well. We're going to skip 7 for right now because that's a little bit more complex. That one requires a couple of procedures. It's divisible by 8 if the last 3 digits are divisible by 8. In other words, take your last 3 digits. Is that number divisible by 8? It's divisible by 9 if the sum of the digits is divisible by 9 if it ends in 0. It's divisible by 10. So those are rules to help you see, because we're going to need to know this is when we start having numbers, how are they divisible? What are the prime factors? Again, have these rules next to you when you do those things. So in this section, we're looking at greatest common factors and grouping. If anybody needs a sheet over, tell me. I'll put it back up there. Okay. Find the greatest common factors of the following numbers. 30, 20, and 15. What is the greatest common factor? Nope. The first thing we have to do the numbers. So we have 30, 20, and 15. Factor them. What is 30 factored into? Yeah, 30 is 3 times 10, 2 times 5. So it's 2 times 3 times 5. What does 20 factor out into? 2 times 10. So it's 2 times 2 times 5. What does 15 factor out into? 3 times 5. the greatest common factors. So which numbers do all three of them have inside the second column? So 5 is a GCF. What you thought about was the greatest common multiple. The greatest common multiple is 60. That's where all three of these numbers fit into. We're looking at factors. What are the smallest pieces of these things that they all have in common? They all have a 5 in common. Let's look at 42, bless you. 42, 28, and 35. Since I knew that 42 is divisible by 2, it ends in an even number, I divide by 2. So 2 goes into 42 21 times. So 2 is a prime number. 21 is made of 3 times 7. 28, also divisible by 2. 2 goes to 28 14 times. So we have that. So the only thing they have in common is 7. That's a GCF. Well, 18, 26, and 32. So 12 is made up of 2 times 6. 6 is 2 times 3. 18 is 2 times 9. 3 times 3. 2 times 13. 2 times 16. 2 times 8. 2 times 4. So it's 2 times 2 times 2 times 2 times 2. So they all only have a 2 in common. So the GCF is 2. Okay. These, well, then we'll move on after these. All right, so I create my box and I have each number. 10 is made up of 2 times 5. 15. 15 is 3 times 5. 21 is 3 times 7. So what's the GCF? You have to have something. What is in every number? Every number has a 1 as a factor. These were what we called prime factors. They can't go any further. They have nothing in common, prime factorizations. So we're done with them. If there's nothing in common for the GCF, it's a 1. You have to have a number. Okay, let's look at numbers and letters now. Six m to the 4th, 9m cubed, 12m to the 5th. I create my little chart here. This one's almost identical to the other ones. One small change. Okay, for the 6, we had 2 times 3, 9 is 3 times 3, and 2 times 2 is 4. So what's the numeric GCF? What number do they all have in common? They all have a 3 in common. And how many m's do they all have in common? They all have 3. So the variables are easy part. They can only have as much as the smallest exponent of the variable. Can m to the 3rd have 5 m's? No. But everybody else can have 3 m's. So the variables are the easy part. The numeric part is what we have to work on. Okay, how about this next one? Don't look at my board. Do yours first and use mine to check it. Okay, they both have a 2 and they both have a 3. So 2 times 3 is 6. This one has all P's, this one has all Q's, so it has nothing else. So the GCF is just 6. All right, it gets easier when you notice there aren't any numbers. There are no coefficients. The numbers are the hard part. When you have just letters, the greatest common factor, do they all have X's? No, so X's can't be the GCF. So now when they all have Y's, you can only take the smallest number. So the GCF has to be the smallest exponent of the variables. Because this one has 8, this one has 9, this one can't go any further. It's stuck at 2, so they all have 2. So Y to the second is the GCF. How about this one? So do they have anything in common? What's the GCF? 1. We see automatically that X and Y, they have nothing in common. So 17 is a prime number, so it can't go in there. So that's as far as you can go with it. So that's how we look for GCFs. Why do we need to know this? Because now the equations get a little bit, we haven't talked about equations. Those are just statements. How about this one? if you had that, factor it. This is called factoring by GCF, by the greatest common factors. What we're doing here is remember the distributive property. We're starting from this side. We want to end up with this. We want to go this way. So what we could do is 4 is made up of 2 times 2. 6 is made up of 2 times 3. So what do they have in common? They both have 1, 2. And what else do they have in common? They have 1x. This one is x squared, so it's x times x. So they both have 1x in common. So far, so good? Whenever you factor something out to see what goes inside here, take this number and divide both of these. So the 2's cancel, one of the x's cancel. So what do I have left? 2x. The 2 cancels and the x cancels. All I have left is 3. And then check your answer. Multiply these together. If you multiply these together, it should come up with that. 2 times 2 is 4. X times x is x squared. Positive, positive. 2 times 3 is 6. X. Check. So that's the right answer. Ten x to the 5th minus 8x to the 4th plus 6x squared. What do they all have in common? Well, 10 is made up of 2 times 5. 8 is made up of 2 times 2 times 2. 6 is made up of 2 times 3. So what do they have in common? They all have a 2, so we get rid of the 2. And they have 2 x's. So we have 2x squared. That's that part. What do we have inside the parenthesis? 5x cubed minus 2 times 2 is 4. X squared plus 3. Again, to see how you get these numbers here, since I knew I took out a 2x squared, if I went to this original equation and divide each one by 2x squared, since I factored out, 10 divided by 2 is 5. 5 minus 2 is 3. So that's what that. So I subtract 2. 8 divided by 2 is 4. 4 minus 2 is 2. X's cancel. 6 divided by 2 is 3. So that's easy way to check your answers. Factor this one out. So what do they both have in common? They both have m's, right? How many do they both have in common? How many m's? They both have 7 m's. Now, what goes inside the parentheses? So as I took this out, I divide both of these by m to the 7. M7 divided by M7 is what? 1. And then this is 7, so I subtract 7, so we have m squared. So there's my answer. So M7 equals 1. (15x³ minus 10x² plus 5x). So what do they all have in common? Yeah, they each have a 5 in common and 1 x. You cannot have more than this many number of x's. So if I divide each of these numbers by 5x, because I factored out the 5x, so I divide each of them. The 5's cancel. 1x is gone, so I have 3x². The 5's are gone, and I lose 1x, 2x, 5x is 1. There's your answer. And it doesn't matter how many variables we have, same thing occurs. All right, what number do they have in common? Or just the number. What numbers is 8, 16, and 12? What do they all have in common? Well, let's look at this. So this is made up of 2 times 2 times 2. This is 2 times 8, which is 2 times 2 times 2 times 2. This is 4 times 3, 2 times 2 times 3. So they can only have 2 2s. So they all have a 4 in common. How many x's can they have in common? Yeah, they only have 4 x's. How many y's? The smallest is 2. So everything else fits inside the parentheses. So if I divide this first one by 4x to the 4th y², 8 divided by 4 is 2. X 5 minus 4 is 1, and x are gone. And the next one, divided by 4x to the 4th y². 16 divided by 4 is 4. 6 minus 4 is 2. 3 minus 2 is 1. And divide the last one by 4x to the 4th y². 12 divided by 4 is 3. The x's are gone. 7 minus 2 is 5. So there's my answer. The answer is 4x to the 4th y squared, 2x plus 4x squared y, 3y to the 5th. That's the answer. So far, so good. Negatives. We haven't thrown those in. What if your leading term is negative? What if your leading term is negative? If leading term is negative, steps. Factor out the negative. That's your first step. So we're taking out the negative. If we take out the negative, what happens to all these numbers inside there? They change their signs, yeah. So this becomes positive 14x cubed y squared. This one now becomes positive 21 x squared, and this becomes negative. I took away the negative, so I changed everybody's signs. Greatest factor has the greatest common factors. So what number do they have in common? Yeah, 14 is 2 times 7. 21 is 3 times 7. 7 times 1. So we have a 7. They all have in common. How many x's do they have in common? 1. How many y's? Very good. So we divide each of these by 7xy. (14) divided by 7 is 2. 3 minus 1 is 2. 2 minus 1 is 1. 21 divided by 7 is 3. 2 minus 1 is 1. 3 minus 1 is 2. 7's x, those all cancel, so it's 1. What do you think so far? Is it complicated? It's the same stuff we've been doing all along. Is look what they have in common, take it out. And with the exponents, since there's a 1x down here, I have 3 minus 1, 2 minus 1. Subtract 1 from the exponents. Top minus the bottom. And this one? On which part? On this one here? Here? Oh, there's 3 by, this is 3 times 5 equals 50. That's E. That's D. I'm sorry, it's E. Okay, yeah. Because I asked you what they all had in common. So what is 8? If you look at these 3 numbers, 8, 16, and 12, what's the largest number they all have in common? You said 2. I said, okay, let's see what 8 is made up of. 8 is 2 times 2 times 2 is 8. 16 is 8 times 2, so it's 4 2s. 12 is 2 times 2 times 3. So they all have at least 2 2s. 2 times 2 is 4. And that's it. So that's all they had in common. Now, what goes inside here? This one has 1 2 remaining. This one has 2 2s remaining. This one just has a 3 remaining. Yes. If they all had a 3 in there, yes, then you have to, yes, exactly. So whatever they have the same in common, you put it there and then multiply it together. I hear it, coefficient. Yes, that's exactly right. Factor by grouping. How many terms are there? How many terms do I have? 2 terms. Because here's the plus that separates them. This is 1 term, that's another term. What do both of these terms have in common? T minus 4s. They both have a T minus 4 in common. So I can factor that out. So in the second parenthesis, whatever the coefficients are goes inside the second parenthesis. And there we have it. That's the factored form. Okay, how about this one? What do they both have in common? X plus 2. So we factor that out. Since we were, you can look at it this way. Since we wrote that there, what do we have left? The X plus 7. How about that one? No, these are all Y's. So Y plus 2 is factored out, leaving me with. Right. So whatever goes in front is the second parenthesis. They both have an X minus 1 in common. So the X minus 1s are gone. What do I have left? The coefficients. The coefficients will go in. If these terms are the same, the coefficients belong in their own parentheses. Okay. Let's see how that's going to be used. XY plus 5Y plus 2X plus 10. Here we have 4 terms. Can we factor them? Since we have 4 terms, the first thing we're going to look at is by grouping. Put the first 2 together and the last 2 together. Just put parentheses around there. Now, what do they have in common here? They both have a y, right? So we take out the y. Plus, there's a plus. What does the second one? What do they both have in common? They both have a 2 in common. So if I divide both of these by 2, I got x plus 5. Now I'm down to only 2 terms. Do they have anything in common? And then the second parenthesis will have the coefficients. And there you have it. So whenever you have 4 terms, look at grouping them first. How about this one? We have 4 terms, so let's just go ahead and try grouping. What can come out the first term? So we take out the y, so we have 2x plus 3. How about the second one? We're taking anything else out? So what's our factor going to be? They both have a what in common? Very good. Excellent. Because there's a 1 there. There's a 1 in front of there. Excellent. So I put parentheses in the first 2 and the second 2. What does the first one have in common? So if I take out a 2x, if I divide both of these by 2x. So x's 2's are gone. x2 divided is this x. 4 divided by 2 is 2. X's are gone. How about the second one? Divide both sides by 3y. 3's gone, y's gone, so just x. 6 divided by 3 is 2. The y's are gone. This is what's more important. If we don't have that, we can't go any further. Whatever's inside the parentheses has to be the same. So now, since both of those are the same, I just put the coefficients in the second parenthesis. And there's my factor. Now, so far, the last 3 examples I gave you, we always had in the middle was always a plus. If we have a minus in the middle, if we have a minus in the middle now, Yes, we put parentheses on the first two, but in the second one, we have to include the negative. If you have a negative in the middle, a minus sign in the middle, include that in your parentheses. If negative in the middle, include it in the second parentheses. Repeat the same process now. What's the first parenthesis? What do they both have in common? So if I took away two x's, I get x. If I took away two x's, I just have a 3. So I divide by x squared. Now the second one, since that's a minus sign there, we have to factor out a negative also. They both have a negative 5. So once you take out the negative, that changes the signs inside the parentheses to positive. So if I divide both of these by -5, negatives cancel, 5, we just have x. Negatives cancel, 15 divided by 5 is 3. So whatever you factor out, you divide by them, and you'll see that now we have the same numbers. So x plus 3, and what was in the second parenthesis? Coefficients, right? Let's try another one of those negative ones. We have xy plus 5y minus 2x minus 10. We're doing what we're doing by grouping now. Are you familiar with that grouping? Okay. I thought we did it before earlier in the semester, but now since there's a minus sign in the middle, things change just a little bit. Since there's a negative sign in the middle, I put parentheses on the first two and then incorporate the negative sign in the second parenthesis. What does the first parenthesis have in common? They just have a y in common. So if I divide both sides of these by y, I got x plus 5. Now in the second one, what do they have in common? There's a negative, and they both have a 2. So if I divide both of these by -2, cancel. We have x, negative and negative, positive. 10 divided by 2 is 5. So we have the same things. So x plus 5. And the second parenthesis are simply the coefficients. Sometimes things don't work out the way we want them to. Can we use the method here? If we put parentheses on the first one, can anything factor? Anything factor the second one? A 3, but it's not going to be the same. So it doesn't mean it's not possible. we may have to rearrange them. Try different combinations. For example, this one has an N, this one has an N. Let's put them together. So what can we factor out of the first one? 3m. So divide each of these by 3m, 3n, not m. Nine divided by 3 is 3. The n's cancel. So we have m. 3's cancel, n's cancel, so we're just 1. Looking at the second one, the first one, the m's are in the wrong position. I can rewrite these. I can have 12m minus 4 on the second one, because I want to have m's first. I can do that because of commutativity. So now, on the second one, what do they both have in common? In the second one, they both have a positive 4 in common, because this number here is positive. If I divide both of these numbers by 4, I get 3m minus 1. So what's inside the parentheses goes first, and the coefficients go second. Okay, so clearly we see that if we move them, if we just do it straight up, it won't give us anything good. So what do we have to move around? You move the 16x over? Okay, let's try it. So we have 12x squared minus 16xy minus 28y plus 21x. Let's try that one. So what do 12 and 16 have in common? Yeah, this is 3 times 4. This is 4 times, they both have a 4, and they both have 1x. So it's 3x minus 4y. Okay, we see here that inside this parenthesis we have x and y, right? This one's yx. So we can rewrite this as 21x minus 28y. So we have xy, xy. 21 and 28, what do they both have in common? A 7, so positive 7. So that's a positive. 21 divided by 7 is 3x. 28 divided by 7 is 4y. So we got it. We have the same number. So 3x minus 4y is the first parenthesis, and 4x plus 7 is the second. There's the answer. All right, so that does it for section 1 of chapter 16. This is different ways we move around. Now we're going to focus ourselves only on trinomials. More paper. There. Basically, what I'm going to do, I'm going to show you all a shortcut on how to do all these. So hopefully everybody knows how to multiply two binomials together. We've done the FOIL technique, haven't we? In multiplying two binomials. The last chapter. So here I have x plus 3 times x plus 2. If we multiply these, it's x times x is x squared. Positive, positive. X times 2 is 2x. 3 times x is 3x. Positive, positive. 3 times 2 is 6. Combine like terms. 2 plus 3 is 5 plus 6. Let's do the next one. So go ahead further. If you know how to do this multiplication part, the foiling, keep on going. Don't wait till I finish all this stuff, because once I finish, I'm going to the next part. So go and work on it. X minus 2x. If you're lost, then you can tell me to slow down and ask me questions. But other than that, if there aren't any questions, I'm moving forward. Again, if you're just waiting for me to copy it down, please don't do that. As you're wasting your time and mine doing that. You're not learning anything, you're just copying stuff down. Work it out. You were copying. All right. We know how to multiply. They're going this way. Factoring goes this way. Starts off with this polynomial and ends up with the two binomials that came from. There's a pattern. The reason I gave you the same numbers, the only thing changed was what in these top four? Plus, 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 minus, minus, plus, minus, minus. Only thing that was change the signs. The changing of the signs is indicated in the final answer. This will help us in factoring. Notice this. The second sign, if the second sign is plus, what does that tell us? It tells us that our equation has the same signs. it's whatever the first sign is. That means since this is a plus and that's a plus, that means in our equation, they're both the same signs. They're both pluses. If it's a plus, that means the same sign, they're both minuses. Minus, minus. So far, so good? When you look at the second sign, if it's a plus, that means the signs are the same. It's whatever the first sign is. Plus, plus. Second sign is plus, so it's the same. They're both minus. That's the first thing I want you to notice. The second thing, if it's a minus, if the second sign is a minus, that means the signs are different. One's plus, one's minus. One's plus, one's minus. But since the signs are different, the bigger number gets the first sign. Since the signs are different, the bigger number of the answer gets the plus. Signs are different, the bigger number gets the minus. So that's going to help us break down our numbers when we start factoring these things. So what we're going to do, we're going to factor out this number, this equation. First step, where does x squared come from? Yeah, x squared comes from this times this. So we know that the first numbers have to be x. The second thing I want you to look at the second sign. It's a plus. Since it's a plus, what does that tell us? The signs are the same. They're both going to be pluses. We haven't done any math. All this so far is observation. Now comes the math. To figure out these two numbers here. Figure out these two numbers here, we have to look at this number. So what number times what number equals 20 when you add them, you get 12. Yeah, 10 times 2 or 2 times 10. So it's 10 and 2, or 2 times 10, doesn't matter. It could be either way. X plus 2, x plus 10, or x plus 10 plus 2. How about this one? What goes in the first spot? X and X. The both signs are the same. They're both what? They're both positive. So what times what equals 18? When I add them, I get 9. Very good. And how about this one? X squared minus 10x plus 24. Again, x's go first. Second sign's a plus. So what does it tell me about the signs? They're both the same. They're both going to be minus. The second sign's plus, so they're the same. It's whatever the first sign is. What times what is 24? When I add them, I get 10. Right. Okay, let's look at some negative signs here. X squared plus x minus 30. Factor that out. Again, same questions. What goes in the first space? X and X. How about the signs? They're different because it's negative. One's positive, one's negative. It doesn't matter where you put them. All we know is what sign will the bigger number have? The bigger number of the answer is going to have a plus. So we're going to figure out what times what is 30. Now, when we subtract them, we get 1. This is that sign. So what times what is 60? When we subtract them, we get 1. 6 times 5 is 30. 6 minus 5 is 1. So since 6 is bigger, it gets the plus sign. So it goes 6 minus 5. Okay, factor that one. So we have x's. The second sign's a minus, so they're opposite signs. The first one's a plus, so the bigger number gets a plus. What times what is 42? When we subtract them, we get 1. 7 times 6, 7 minus 6. So 7 goes in the plus, 6 goes in the minus. The hardest part here is knowing your multiplication table. X squared minus 9x minus 22. Okay, again, start with the process slowly. What do we know goes in the first pot? X and X. What are the signs? They're opposite signs. Since the second sign's a minus, one's a plus, one's a minus. And the bigger number is going to be negative. So what times what equals 22? When you subtract them, you get 9. 11 times 2, 11 minus 2. So since the first sign is a negative, the 11 goes with the negative. And the last one for the day. So we have X and X. What about the signs? Since the second sign's a minus, the signs are different. One's a plus, one's a minus. And the bigger number will get the negative. What times what equals 16? When I subtract them, I get 6. Eight and 2. Since the first sign's a minus, the 8 gets the minus. That's that. Yeah, there are more rules I'm gonna go through, but this is the basis I want to go through first, understanding this. We're almost done with the chapter. So far, we've only looked at numbers where the leading term is 1. We're gonna get to a point where any number could be there. That gets harder, but I'm gonna show you a shortcut for that. All right, that does it for today. We have one more class, and then next week will be your